Okay, let's get started. So 16x to the fourth minus 1. Did we think of anything for this one? So yeah, these are both perfect squares. 16x to the fourth and 1 are both perfect squares. So when you take the square root of each of these, you should get, let's see, 4x squared plus 1. And then 4x, yeah, give me 1 second, 4x squared minus 1. Notice when you look at these, though, these are perfect squares again. This one we can't do anything with because of what? Good, right? This one has a plus sign, so we can't do anything with it. But this one we can because there's a minus. So we're going to factor this side again. This is going to be 4x squared plus 1. That didn't change. But then this is going to be a difference of squares again. This is going to be 2x plus 1, 2x minus 1. Is there anything more that we can do to this? So we leave it alone. This is our final answer. Anyone have any ideas for number 2? John? Okay, good. So notice that 16x squared and 25y squared are perfect squares. So when you take the square root of each of these, you should get 4x and 5y. And our test for this is we want to multiply these together, and then we should get 20xy, bless you, and then double it. And this gets us 40xy. Since that matches the term in the middle, we're going to take the sign in front, stick it in between, and then square the whole thing. So this is our factored expression. Okay, that's a good question. If it didn't match the middle number, there's probably nothing more we can do to it. For now, what you guys have learned, there's nothing more that you would do. But later today, we're going to do any trinomial that doesn't match this special case. So then that would be the next step to do. But for now, with what you guys have learned, you could just leave it unfactored. Do you understand how I got the 20xy?
How do you get the 4x?
You multiply these together. You multiply these two numbers. Do you understand how we got those two numbers, those two terms? Yeah, right. We square root this, square root that. And then you multiply them together and then double it. You always double it. Good. Okay, guys, so we're going to get started. We should be on Chapter P, Section 4, factoring cubes and grouping. Should look something like this. All right, so if you guys haven't opened it already, that's fine. Just get it open. I'm just going to talk for this one. So we learned on Friday a difference of perfect squares. There is a rule for a sum and difference of cubes, right? So with cubes, it can be plus or minus, right? Whereas the squares, it had to be strictly minus. Okay, so our rule for cubes is if I have two perfect cubes with a plus in between, it's going to be two sets of parentheses. In the first set of parentheses, it's going to be the cube root of the first plus the cube root of the second. In the bigger set of parentheses, it's going to be the square of the first minus the product of the two in the middle plus the last one squared. All right. All right, when it's minus, this is going to be u minus v, right? The cube roots of both of these. And then you're still going to end up with the same terms, the u squared, the uv, and the v squared. Just the first one is going to flip, and then the second sign is going to stay a positive. One way that I like to remember the signs, some people mess up the signs, is whatever you see in the middle of the original expression, that's what you're going to base this off of. So this first one is going to be the same sign. The second sign that you see is going to be the opposite sign. And then the last sign that you see is always going to be a plus. So it's going to be same, opposite, always plus. Same exact thing if it was a minus, right? Since you see a minus here, this first sign is going to be the same as what you see in the middle. The second one that you see is going to be the opposite of what you see in the middle, and the last one is always going to be plus. So you can remember that using SOAP. Same, opposite, always plus. Same, opposite, always plus. All right? I'll show you that with an example. All right, so x to the third minus 125. All right, if you don't get it right now, that's fine. Let's just try this example. X to the third is a perfect cube. All right, do you guys agree that x times x times x is x to the third? Yes, no? Yeah, good. So I'm going to take the cube root of that, which is x. 125 is a perfect cube, right? What's the cube root of that? 5, good. Okay, we're going to deal with the sign in a second. What sign do you see in the middle? Minus, good, so negative. So it's going to be the same sign in the first set of parentheses. And then in the trinomial, it's going to be the opposite, always plus, right? So we can fill that out first. Same, opposite, always plus. In this first term right here, it's going to be the first squared. The last is going to be the last squared. So 5 squared is 25. And then the middle is going to be the product of the two. X times 5 is 5x. And there's nothing more we can do to that, so this is our final answer. So just like the previous page, I'm going to do number 1 with you guys. We're going to do 2 together, and then I'm going to let you guys try 3. So number 1, again, these are both perfect cubes, and there is a minus in between. So if you don't want to do anything first other than set up your signs, that's perfectly fine. So it's going to be the same sign, the opposite sign, and the last one is always plus. So same, opposite, always plus. You can set those up right away. We can start with the cube root of x to the third, which is x. And we can do the cube root of 27, which is 3. So I can fill that in the first set of parentheses. In the second set of parentheses with the 3 terms, it's going to be the first one squared. In the last spot is going to be the last one squared. 3 squared is 9. And the product of the 2 in the middle. 3 times x is 3x. There is nothing more you can do to that, so this is your final answer. All right, we're doing a little bit better. Okay. All right, now let's try the second one. All right, so let's do it together. So I'm going to set up the parentheses. What sign should go in the first set of parentheses? A plus, good. I'm going to start with the signs, and then we can do the terms. So I'm going to do the same, which is plus. What's the next sign that you should see? A minus, good, opposite. And then what's the last one? Plus, right? That one's always plus. Now let's actually fill these in. What should go in this first spot? Y. What should go in the second spot? 2, good, right? It's the cube root of both of them. What should go in the first spot of the second set? Good, the square of the first. What should go in the last spot? Square, right, square it and you get 4. And then what should go in the middle? 2 times y, good. Nothing more we can do with that. That is our final answer. Making a little bit more sense? Nice. How about you guys try the next one? Okay, good guys. So let's try it together, right? I'll show it on the board. The first thing I'm going to do is set up the parentheses. I see a minus in the middle, so before I do anything else, I'm going to assign the signs just so that I don't forget it and I make a little mistake later. So it's going to be the same, opposite, always plus. This one is going to be, the cube root of this whole thing is going to be 4x. The cube root of 1 is just going to be 1, so we get 4x minus 1. In the second set of parentheses, it's going to be the square of the first. You're squaring the entire thing. So 4x times 4x is going to get you 16x squared. The last is going to be 1 times 1, which is 1. And in the middle is going to be the product of these two numbers. The 4x and the 1 is just going to get you 4x. Nothing more you can do with that. So that is our final answer.
So you ignore the sign.
What about this one, right? I saw some of you maybe stopped on this one. We can even stop at the first term. Is this a perfect cube? No, right? 3 is not a perfect cube. So what do? Give up? What can we try? Gabriel?
You can divide them both by 3.
Good, right? So these two, we can try to take out a factor of 3. Maybe you don't know off the top of your head if 192 can be divided by 3, but we see a 3 in front. That's the only thing making it not a perfect cube, so it's worth it to give it a try, right? Let's try to factor that out. When we take that out, this one we get x to the third, right? Let's divide each of these by 3. What did we get for the second term? Good, okay. When you actually do your division, you should get 64. Now look at x to the third and look at 64. Are those perfect cubes now? Yes, they are. So that means you can do your same rule. This is going to be 3. And then set up your parentheses. Do the SOAP, same, opposite, always plus. And now assign each spot with the correct term, right? So what should go in the first set of parentheses? What plus what?
X plus 4.
Good. Cube root of both of them, it's going to be x plus 4. What goes in this first spot? X squared. What goes in the last spot?
16.
16. What goes in the middle?
4x.
4 times x. And then this is our fully factored expression. Are we good with that, guys? Good? Okay, so when you look at something like this, we kind of had an example similar to this when we were doing Friday's lesson with the squares. Even though this doesn't look like the normal cubes that we usually see, it is still a perfect cube because there is a power of 3 to it, right? This one is also a perfect cube. So we can do the exact same thing. You just need to maybe make your parentheses bigger so that everything fits. So I'm going to start with 1 and then another. I see a minus in between, so I'm going to do the same thing, same, opposite, always plus. And now let's assign everything where it should be, right? In this first spot, the cube root of x plus 2 cubed is just x plus 2. And the cube root of y cubed is just y. And now when you do the second set of parentheses, it's going to be this first thing squared. So x plus 2 squared. The last thing squared, so the y. And then, bless you, these two multiplied with each other. So y times x plus 2. The only thing what you would have to do right now is simplify a little bit more on the inside. All right, so it looks like this first set of parentheses is perfectly fine. I don't have to do anything to x plus 2 minus y. Our second set of parentheses, it looks like we might need to do a little bit more simplifying. This is where I would recommend you guys memorize the special product, all right? Because then you're going to have to FOIL within this problem, and that might be a little bit messy. If you remember your special product with the square of a binomial, it's the first one squared, the second one squared, so x squared and 4 squared, and the product of the two in the middle doubled, right? So this one's going to be 2 times x times 2 is going to be 4x. That's how I got this first thing cubed. If you don't believe me, you can FOIL it on the side, but I definitely recommend you guys remember the special product. With the y times x plus 2, you can distribute that y. That's going to get you xy plus 2y. And then we end up with just the regular y squared. Are there any like terms inside of that parentheses? No, it doesn't look like it, right? So this would be our fully simplified answer. All right, so when you're factoring by grouping, this is where you have 4 terms. You're going to group them in pairs, and you're going to factor out the GCF until the parentheses match. Once you factor out your GCF, you should have that the parentheses match, and then you can factor that out. And then you've grouped together whatever's left over. All right, a lot of words. Let me show you what that would look like. So in this example right here, how many terms do we see? 4 terms, good. So I'm going to group the first two, and then I'm going to group the second two. What's our GCF of the first set of parentheses?
X squared.
Good. And then what do we get when we take out x squared?
X.
Good. X, what is that? X minus 1, good. What about our second set of parentheses? 2, good. So I'm going to take out a 2. And then when you take out a 2, what's left over inside? Good, x minus 1. What do you notice about this parentheses and this one? They're the same. When they are the same, it's going to show up once. And then whatever you pulled out is going to be its own set of parentheses. So x squared plus 2. And that is fully factored. Let's do a little bit more. We can look at this first one. Again, how many terms do you see? 4 terms. So I'm going to group the first 2. And then I'm going to group the second 2. What's our GCF of that first set of parentheses?
2x squared.
Okay, we can take out a 2x squared. To get what's on the inside, you can divide everything by 2x squared. And then what do we get inside? 4x cubed minus 3. Good. What's our GCF of the next set of parentheses? Good, right? We can take out a 3. When we take out a 3, what's left over? 4x to the third minus 3. Very good. Do our parentheses match? So how many times am I going to write it now? Just once. 4x to the third minus 3. And then what shows up in the next set of parentheses? Good. We're going to put together this GCF and that GCF. This is going to be 2x squared plus 3. Okay, that's a good point. If you guys remember what we were doing on, Friday, notice that this and this are factors. They are being multiplied with each other. This and this are also factors. They're being multiplied with each other. So if you see 2 of the same factors, you treat that as a GCF. All right, what does that mean? That means this and this, since they are common factors, you pull it out, and you're really pulling out a GCF. All right. I'm just going to do this last one. Actually, you guys can give it a try. Okay, nice, guys. Let's go over it. Okay. So same process as before. Let me just point out some little things that I notice. I notice these all the time. Every time people do grouping, it's always some of the same issues. So when you're writing around your parentheses, keep the sign in front. So keep that negative in front of that negative 5x. Some people, when they find that things aren't matching, it's usually because of that. Just make sure you keep the parentheses around everything. There shouldn't be any gap here. All right. Another thing that I notice, right, you can tell the GCF of the first set is x squared. You should be left with x plus 1, right? It looks like most of us got that. The second one, it looks like you can take out a negative 5. That's also going to give you an x plus 1. If these aren't matching, make sure you're pulling out a negative when appropriate, right? Some people think that this one looks similar but isn't quite matching. See if pulling out a negative fixes that issue. Another thing that I see, some people just leave it like this. This is not factored. You still have to pull out this as the GCF. All right? So when we pull that out as the GCF, this and this, that's going to show up once. And then in parentheses is going to be the 2 GCFs that we found, x squared minus 5. And that's fully factored. All right, are you okay with that, guys?